All right. Um, you have learned right the sequential rules, right? Priority rules and transition rule. Um, now you learn how to save right the assignment cost for the resources. Let's say your work center have a number of the resources, right? Again, the resources may be the machine, may be workers, right? And those resources, right, have ability to process all of the jobs, right? Um, but you want to manage um, the time in the economical way. So it means that you want to minimize the assignment cost. Of course, you can assign any worker or any resource to do the work or to do the job, but um, if you want to save the assignment cost, you need to use the assignment method, which you're going to learn now. All right. So the objective of the assignment method is to minimize the cost of assignment. Uh, right. Suppose you already got the table of the cost or the time associated with a particular assignments. Um, in this data table, you see there are three resources A, B, and C, uh, and the list of the jobs, right? And you also know the information how much each resource to complete a job. For example, uh, it costs $11 for A to complete job R34. It costs $14 for B to complete job R34. All right. So suppose you got this table about the cost information. All right. By your intuition, right? You can look at the row R34. That is for the job, right? R34, and you see that in the cheapest assignment cost for C, right? To do job R34, right? It's $6 to complete this job only, compared to 11 if of if this job is assigned to A, and $14 if this job is assigned to B. Okay, so intuitively you can say that resource C should be assigned uh, with job R34. But it but is there any systematic method to solve this kind of the problem, to solve this kind of assignment problem? Yeah, that their procedure, right? So now you're going to learn that procedure. All right, and now begin with step by step procedure, right, for assignment problem solving. All right, using right this data table again. Uh, you follow step by step procedure, right, for assignment, with the objective of cost reduction. Step 1A, rows subtraction. All right, so you consider the number as the number table here as the matrix. All right, and step 1A is you conduct the row subtraction for each row. Begin row 1 R34. You subtract all of all of the numbers in this row with the smallest number in that row. Okay, the smallest number is 6, right? You subtract all of the numbers on row R34 with 6. from 6, right? 11 minus 6, 14 minus 6. Okay, and you receive, you can see the result, right? In table step 1A. Okay, after you finish the step 1A, you you take the step 1B, column subtraction. For column subtraction, you look at the column, right? You look at the column, right? The column A, for each column, for example, A, you subtract all of the numbers in that column from the smallest number in that column. The smallest number in column A is 0, right? So 5 minus 0 is 5, right? 0 minus 0 is 0, 2 minus 0 is 2, right? Column B, the smallest number is 2, right? 8 minus 2 is 6, right? 2 minus 2 is 0, 5 minus 2 is 3. All right. And you see that the new table in the step 1B for B column is like this, 603. And for C column, 030. All right. Now, after step 1B, you take step 2. That is the line, okay? Line crossing. Line crossing. But you cross the line, you use the line to cross the number on the condition that the number you use for crossing is the minimum number. Okay. So how can we know that we have the the minimum number of the line crossing all of the zero? Okay. We want to cross all of the zeros, right, with the smallest number of lines. But how can we know that we use the smallest number of lines to cross the zeros? Just simply, right, look at the rows or the column with 2 or more zeros, and cross the line, right? So you see in rows S66, right, there are 2 zeros. All right, so you just cross the line. So it means that you use only one line to cross 2 zero, right? All right, so here look at it, the reverse one. Of course, you can use 3 lines. All right, for example, 1 line to cross 1 0, 1 line to cross 1 0, 1 line to cross 0, or maybe more 3 lines, right? But that's not the optimal way, right? Because we want to use the smallest number of lines crossing the zero, right? So we select the row with 2 0. The row with the 2 0 is as the S66, right? Okay. So we cross 1 line, right, to cover the 2 0 in the row S66, right, and another line to cross all the 2 zeros in column C. Okay. Next, we check if this solution is optimal yet. The condition for the solution optimality is the number of the crossing line is equal to the number of the column, right? You can raise the question, oh, what happened if what happened if the number of the column is not the same as the number of the rows? All right, so if that is the case when the number of the columns is not the same as the number of the rows, you can use the dummy. Okay, so let's say if there are 3 columns but there are only two rows, you add additional row which is a dummy row, right? So that you can follow the steps in this assignment method. All right, so the optimality condition is that the number of the Gaussian lines is the same as the number of the columns, right? But unfortunately here, there's only two lines. Okay, so the solution is not yet optimal. So what should we do next if the solution is not optimal yet? Uh, so if the solution is not optimal yet, right? We need to improve the solution, of course. Right. So how can we improve the solution? All right. So you look at the uncovered or unselected number, right, in step 2 table, right? And we know that the unselected numbers are 5, 6, 2, 3. And then you pick the smallest unselected number, which is 2. All right, which is 2. And then you add this smallest number, right, to the intersection of the line. The intersection place of the two lines is 3, right? So 3 plus 2 is 5. Okay, and then you minus 2 from all the unselected number. For example, 5 minus 2, 6 minus 2, 3 minus 2. All right, and then you got the table in step 3 here. Okay, 5 minus 2 equals 3, 6 minus 2 equals 4, 3 plus 2 equals 5, and 3 minus 2 is 1. All right, now after you already done this step, you check the solution optimality again, okay, by using the lines to cross the 0. Again, remember that you use the smallest number of lines to cross all of the 0. Okay, so select the column with the 2 0 or more, right? Column A, 2 0. Okay, it's good, right? So cross it, right? B, same, C, same, right? And now you count the number of the line, which is 3 now, 1, 2, 3, which is this equal to the number of the columns, and then you decide, oh, now the solution is optimal. Right, so when you already identify that the solution is optimal, the final step is you assign who will do what, or which resource will do which job. Okay, which resource will do which job. All right, so look at the step 4 table. That is the final solution, right? Final solution. All right. So resource A, can do S66 or T50, right? Because there are 2 0 here. Okay. Okay, again, resource A can do S66 or T50. So which one is better? Which one is more economical? Which one is cheaper? Okay. We don't know yet. All right, we don't know. Right, so temporarily you skip assignment for A, right? Now move right to B. Okay, there's only 1 0 for B. Okay, so it means that B should be assigned to do S66, right? Okay, look at the cell 0, and the cell 0 will tell you who will do what. Okay, so B B should be assigned to do S56 for the smallest assignment cost, right? All right. So uh, when job is already been assigned, you can eliminate, right? You can eliminate that job. So two jobs remains, R34 and T50. All right. Now you go back to A. So the remaining job is T50. Okay. So it means that I now can do T50. All right. Okay. Let's add here. For B do S66, right? And A to T50. All right. So after T50 has been assigned to A, you eliminate T50, right? The remaining job is R34. Okay, and things become very easy for you now, right? C can do R34. Right? C can do R34. All right. Yeah. Now done. But actually, you may calculate the total assignment cost, right? So how can we calculate the total assignment cost? The cost to assign A to do T50 is is how much? You have to look back to the initial table, right? The initial table here, it costs A to finish T50 uh, for $9. All right, and it takes B to complete B to do what? B do S66, right? It takes B to complete S66 for $10. All right, and it takes C to complete R34 for $6. Right, so 6 plus 10 plus 9 equal 25. So 25 is the minimal cost for assignment using the assignment method. All right, so that's it. Any question? All right, if no question, right, let me wrap up, right? Today you learned short-term scheduling in operation management. You learned the contributions of the short-term scheduling to the organization strategy, right? Especially for the cost strategy, because the way you schedule um, when to do a job, right, can save, right, some assignment cost. Okay, you learn how to use priority rules. Okay, for the for a single resources case, and you learn to use the Johnson rule for the two resources case, and you also learn how to apply the assignment method to minimize the assignment cost. So there's a quiz, right, on your blackboard, right? You do it, uh, okay, and submit in time so that you improve your total weekly quiz score. All right, any question? Any question? Thinking, thinking. Hoa Kim in the class or she's still not yet?
Yeah, she just add and insert many times.
Yeah. Okay. Uh,
I uh,
what is the
I don't
deadline of
understand.
S50? Hmm?
Sir, I don't understand well about the Johnson rule in the work sentence too. Could you explain again about Johnson rule
Johnson rule, all
example?
right. Johnson
Work
rule.
sentence and work sentence too.
Johnson rule. All right. Johnson rule. Work center two. Here, right?
Yes.
All right. So just imagine the machine two is the drying machine. Máy sấy. All right. In your laundry shop. All right. The you have to wait for the right the bundle of the dirty clothes be right finished in the washing machine. Okay, let's say the machine one is the washing machine, right? So it means that the drying machine is idle, right? Is idle while the job is being processed in the washing machine. You got it? If
Yes.
the washing machine, if the washing time, right, for be in the washing machine is 3, then the idle time, right, of the drying machine is 3. All right. Okay. You cannot dry any dirty dirty clothes, right? So the drying machine has to wait, and uh, and you have to follow the sequence you already identified. The sequence is B, E, D, C, and A, right? Right, and for the sequence, right, you just